So it's Easter weekend and I've been getting phone calls thick and fast today with people asking me if they can pick my brains and also whether I can help them with various problems they've got. Now, it's got me thinking because I've probably said the same thing 4 or 5 different times today, and it's trying to get people to understand how the systems work. And most of the time, once I've kind of talked over what the systems are and how they work and how they kind of work together, then the problems, they don't solve themselves, but at least the customers can start looking at where they need to look. Because I can't go out on site at the moment because we're so busy, and I'm here by myself half the time anyway. And 9 times out of 10, we don't actually need to go out to the caravan. It's something that is fairly obvious once you know how the systems work. So that got me thinking. I thought, well, should I do a few videos just kind of talking about the basics and how the different systems kind of work together? And once you understand that, then like I said, you can then start to kind of solve your own problems, and it could save you a call out fee. It could save, worst case scenario, you going home halfway through your holiday because the caravan's broken, and it's a relatively easy fix. Also, I'll be talking about a few different things that I think that if you had in your toolbox, you could solve 90% of the problems straight away, or at least they can point you in the right direction. And that is a 12 volt tester and a volt stick, and I'll talk about those in a second. So let's talk about how the systems work together. Now, you'll probably be aware that there's a 12 volt system and there's a 240 volt system in the caravans, and they kind of work independently, but they also join together. And understanding how these two systems work is key to understanding what problems you've got and how to kind of get around them. So the battery is responsible for working the 12 volt system, and the 12 volt system will be your internal lights, it will be your water pump, your spark generators, your toilet pump, and they also work the printed circuit boards, kind of the brain of your water heater, your space heater, and the fridge as well. So without 12 volts getting to the printed circuit boards or the brain of the appliance, they don't work. So you can't just feed it to 240 volt and it'll work. So you need to have 12 volts to those as well. So how the system works on the 12 volt side of things is the battery does most of the work, and then the transformer will charge the battery up when it needs it. And that's where the 240 and the 12 volt cross over. So the 240 is responsible for your microwave, for feeding doing the heavy work in your fridge and your water heater and your space heater. But again, like you said, you need the 12 volts in conjunction with the 240 volts for that to work. And it does your sockets and things like that as well. So that's what the 240 does, and then the 12 volt does all the light work. So with your battery working in the correct condition, you can disconnect your 240 and then your lights will continue to work. And that's how you test to see whether your battery's working independently or not. And if you haven't done that for a while, that's the first thing to do, because if you plug in all the time, the charger transformer will override any issue with the battery because it fills the system up with 12 volts. Now, or 13.8 to be precise. So if you haven't done this for a while, it's a good idea to turn the light on, disconnect your 240 or turn it off at the RCD, the trip switch, and then see what happens to the lights. If the lights go out, that means your battery isn't working correctly. Either the fuse has gone, there's an issue with the battery, it's gone completely dead, or you've forgotten to connect it, which we've had that before as well. So it's a good idea to do that. And then also what that does is make sure that the battery is in good working condition and your transformer isn't doing all the work. So if your battery isn't actually in the system and not working correctly, the transformer thinks, oh, I've got to charge the battery all the time, because it's not seeing it, it's not there, and it will keep going and going and going. And the vast majority of the transformers chargers aren't designed to do that. They're really only designed to feed the battery when it needs the 12 volts, and then it should cut off again. But if it's not there, obviously it's going to keep on running and running and running. Eventually it will pack up, and then that's when everything goes dead, normally in a really bad inopportune moment, and that then you've got nothing at all. You can't heat the caravan, you can't have any hot water, you've got no lights, you've got no water pump, everything's completely dead. So before you get to that point, check that your battery's working correctly just by disconnecting your 240 and making sure you get lights. If you've then got a dial or kind of some way of checking the battery in the Caravan system, it will be around about 12.7 volts when it's fully charged. If you put the charger transformer on by turning the 240 on, it should go up to 13.8. So that gives you a good indication that your transformer is then working, because it will kick it up a little bit like that. You'll see it physically move, so that it goes to kind of a charging voltage then. So if we get a phone call with a customer saying that my lights have gone out, my battery's depleting, they tend to think that it's a problem with the battery, when in reality it's probably a problem with the charger transformer. Now there's several reasons for that. The vast majority of the time the transformer is just packed up and you have to replace it, and there's several different types of that. The BCA, which are in Bailey's and Coachman's and Luna's. I do have a video of how to replace that, which I'll put in a link in the end. So if you do have that transformer charger pack up, that's relatively straightforward to do. Certainly if you've got a newer one, because it just kind of slides out and you slide the new one in, which is really handy. So if you find your batteries going dead and you are plugged into 240, it's probably not the problem with the battery. It's probably something to do with the transformer. It also can be 240 voltage to the transformer, so you need to establish whether you've actually got 240 going to the transformer, and that's where the volt stick comes in. And this is a fantastic piece of kit. It's about £10 from Amazon or DIY shops, or anywhere like that, builder centres. But if you get one of these and you touch the cable, it will light up, and some of them beep depending on which one of these you've got, and that will tell you that you've got 240 actually going to the appliance. And that is one of the best things you can know, because there's no point replacing the transformer or whatever appliance it happens to be if you haven't got 240 there. The combi boilers, I use this a lot with the combi boilers, because if you've lost power to the combi boiler, so you haven't got your little plug symbol in the kind of the mid right hand section there, it could be a problem with the actual boiler itself, or it could not have 240 going to it. So if you get one of these sticks and you find the main fat wire that goes into the combi boiler itself, and you touch that and it goes beep and the light comes on, you've got 240 going into it. So that's not the problem. It's a problem actually in the boiler itself. And then there's other reasons, other ways you can fix that, hard resets, and there's a little fuse in there as well, which I've probably got other videos on. So having one of these is absolutely brilliant, and this is how it works. So to use a volt stick, which is this thing here, I've got my handy T-urn here, which gets a lot of use in the office. So if you get the volt stick and go anywhere near where 240 is, then it will light up. Some of them beep. There you go, that's beeping as well to tell you that you've got an audio signal. Okay, so that's telling you that there's 240 going through that cable. So obviously all you need to do is get that volt stick and put it onto any cable that you want. Sometimes you have to move it around because it is insulated, and you have to get it where the positive or the live is close to the edge. So you have to kind of wave it around sometimes to get it to work, but generally it will pick it up. Okay, and that will tell you that you've got 240 going into an appliance, and it can save you a lot of trouble if you haven't got 240, and that's the issue rather than the appliance itself. And there you go, nice and straightforward. Get one of those, 10 quid, can't go wrong. So definitely recommend getting one of those. For the sake of the tenner, it's absolutely fantastic. It will tell you what you've got or what you haven't got, and therefore you can then start looking at somewhere else. Or 9 times out of 10 it's because it's tripped out on the park, but people didn't realize that was happening, because you still got 12-volt lights, and again, not seeing a relationship between the two different systems. So get one of those, test the wire, and it will tell you whether you've got 240 or not. Another really handy piece of kit to have and to understand how it works is this. This is a multimeter. Now it looks complicated and confusing. There's only a couple of settings you actually need to know on how to work on this. I don't know most of these. All I know is on the voltage, you've got the 20 there, and that's above 12. So it will register 12 volts without going off the scale. Now what you do is put that on, I'll show you in a second. You put this onto a battery, and that will tell you that you've got obviously negative and positive. That will then give you a reading of what's in that battery. Now, also then you can put it onto cables. So if you've got plus and minus going into something like the combi boiler, for instance, there's a blue and a white wire. You can put this on the blue and the white wire, because I think blue is positive and white is negative, and then that will tell you whether you've got voltage there. Again, most of the problems we'll have with the actual combi boiler is the fact that it isn't getting the voltage that it should do, so it will throw up a code. Then you can start looking at the Caravan itself rather than the heater. So it's very important to understand what you're looking at. And I spent hours and hours and hours looking at the wrong thing, thinking, why isn't this working? Only to find out, A, I probably haven't switched it on, or there's no power getting to it because I forgot to do that. So this is a really good thing to understand how to use. So you get one of these. Again, they're a couple of quid on eBay, on Amazon, or a tenner or something like that. There's not much to them. And then just practice with your battery, and then it's a really good thing to understand. Also, you can test continuity. Now, continuity is when you put it on one end of a cable and then it goes through, it comes out the other end of the cable. It tells you that there's no breaks in the cable. Again, that's a very good thing to understand, especially with fuses. Now, I've spent hours working on something only to discover that the fuse looks okay, and I've held it up to the light, no, not a problem at all. Then I thought I'd just put a continuity test on it, which tests it without having to visually see it. It puts a cable current through it and tells you whether it's actually going all the way through or not, only to discover that actually no, it's not. There's no continuity there, which means there's no power can get through when you actually give it power, and therefore it's the actual fuse. So that's a really good thing to do, and this is how you do that. So this is how a multimeter works. I've set it to 20, as you can see there on the voltage. You've got AC, which is alternating current, which is the 240, which is that one there, and you've got DC, which is direct current, which is 12 volts. So as long as you're on direct current there and 20, then you're okay. The 240 will only go to 200 and 500 because obviously it's 240 volts. So all your lower ranges is where you set it to. So set it to 20, and then we've got negative and positive, and you can see the reading goes to 12.71, which is the battery fully charged up. A battery that is flat will be 12.1 or something like that, but it'll still have 12 volts in it, but it'll have no amps. But that's when you start getting a bit complicated. So all you need to know is that you've got 12 volts there. So within a range of 12 volts from 12 to 12.7, if you test a cable or something that your pump feed or anything like that, and you've got 12 volts to it, you know that there's 12 volts going to that appliance, and then you can look at the appliance having an issue. Okay, so then you take it off. So red goes to positive, and black goes to negative. Now, if you do it the other wrong way around, which you can do in a Caravan because you don't know what the colours are what, it'll only go to negative. So it still tells you you've got it, it's just tells you got it the wrong way around. So you can't hurt yourself or blow yourself up or do anything like that. The only thing you can do, you don't want to touch these two terminals together with wires, so they still spark quite heavily. So if you are playing with 12 volts, just make sure you don't touch any wires together. So just keep them isolated. That's what you need to do. So that's how you use the multimeter to test for voltage. Now, if you want to use the multimeter to test for continuity, just turn it to ohms, which is that one there. That's a little ohm symbol. It doesn't really matter what the range is because it's going to go to open circuit anyway. I think that's right. You might tell me wrong. But all you do then is put one of the prongs on one side of it and one of the prongs on the other side of it, and you can see then it goes down to 0. And that means that there's no resistance. So the power is going through there, through the little wire, down through the other one and out to the other side. Then it tells you that you've got continuity going through. So that means that fuse is okay. So if that fuse had blown, then it wouldn't move. It just stay on one, which means it's completely resistant because there's no way that the power is getting through it. I always check to make sure that the multimeter is working. Just touch them two together just to make sure that that the system's working before you test any fuses. Just make sure you haven't unplugged this or one of these isn't broken or anything like that. Okay, so do that, and then it will go to continuity. So that's the best way to test a fuse. You can look at it, and 9 times out of 10 it'll be blown in the middle and it'd be dead straightforward to see. But like I said, I've been caught out so many times when I think that it looks okay and it's broken down there and you can't see it. And I spent hours looking for another problem and only to find out that has packed up. Okay, so that's how to test continuity. Test the continuity of a fuse or any other wire as well, because anything's the same. So if you've got one wire one end and you want to make sure that there's power going through it, because I've had that before in numerous occasions where a wire is actually broken down in the middle. You can put this on one end of the wire and that on the other end of the wire, and again it will do the same thing. So once you've understood how to test for 12 volts and test continuity, and you've got a screwdriver and a volt stick, I would say probably 80% of the problems that you're going to be getting you can solve. And once it gets to the point where you're going beyond that, that's when it gets complicated and you start to have to delve into things. But honestly, 80% of the time that will solve a problem, and it even comes down to forgetting to switch it on. And then you test it, no 12 volt, what's going on there? Oh, I haven't switched it on. And that's, again, 90% of the time, that's what the problems are. Talking of fuses, another misconception is that the fuse is protecting the thing that it is telling you that it's protecting. So say you've got a 10 amp pump fuse. Now, most people will think that the system has surged and have blown the fuse, and therefore that's why the pump isn't working. That's not how it works. What happens is if your pump goes to earth and creates a dead short, it then blows the fuse, and it actually protects the rest of the system from dead shorts. So if you have a fuse blown, it's a very good indication that whatever that fuse is telling you that it's protected, that is what has gone. So if your toilet pump, I think some of them have got toilet pumps separate, most of them are just say pump, and you've got the toilet pump and the main pump on the same fuse. So if that fuse has gone, it's a good indication that your toilet pump or your main pump has actually gone to earth and blown the fuse. It's not the fact that you'll replace the fuse and then the pump will start working. That's not how it works. And if you do that, and you replace the pump fuse and then you turn the pump on and it blows straight away, that's more indication that the pump has actually failed, and you need to replace the pump, replace the fuse, and then you'll find that actually it starts to work. So fuses aren't protecting the thing that it's saying it's protecting, that you think it is. It's protecting the system from the thing that it's saying that it's protecting, if you see what I mean. So yeah, that's another misconception. People say, oh, I've checked the fuse and it's and it's not blown. Then sometimes they don't blow if the pump doesn't go to earth, if it just fails. It's called I always get this muddled around the wrong way. You'll probably tell me what I'm doing wrong. Open circuit means that it's gone to earth and it's blown it, and then the closed circuit means it's the positive side's gone and it's not connected. So depending on which way it's gone, it will blow the fuse or it won't blow the fuse. So having a non-fuse blown or a fuse blown isn't an indication one way or the other, either of a problem or not. But if it's got a blown fuse, then that's where I start looking, if that makes sense. Hopefully it does. So that's the 240 and the 12 volt systems. So just remember, the battery does the 12 volts, your transformer will charge the battery up, your 12 volts run the lights, the printed circuit boards and all the equipment, and your water pumps and your spark generators and things like that. The 240 run your sockets, and they make the things actually work. Like your fridge is 240 and your water heater is 240. They give the main input to make those things heat up and cool down. And where they join is the charger transformer, and that charges the battery up, so that when you're plugged in, you don't have to keep charging the battery up. So that's how they work. But again, very important to turn your 240 off, make sure that battery is in line and working the lights, and if it's not, it's going to need to be replaced. Just a note on batteries: if you leave them in the Caravan for the length of the winter without being charged, it vastly reduce the length of their usable term. So you need to take it off, take it home, charge it up with an intelligent charger in the garage in the warm, and keep them warm if you can, because they don't like the cold either. So if you leave the Caravan battery in all winter without being charged, the likelihood is it's not going to be in great condition, and sometimes you can't pick it back up again. We have chargers here that can, they're quite expensive ones, but your general charger that you've got at home probably won't. It will just go to fail. So just be aware that if you do that, you're shortening the life of the battery. So take it home, charge it up, keep it in the warm, and you can have a battery that can last 6 or 7 years. So I want to keep these videos rather short. You might have to listen to that 2 or 3 times to kind of get your head around it. I think I've told you what I'm trying to kind of get across to you, of how the systems work. Any questions, pop them in the comments, and I can answer them. Oh, hang on. Sorry, got a customer. And then like, subscribe, and check out My Ideal Caravan. That will tell you lots of other things there as well, with other videos on there. So check out My Ideal Caravan and sign up to that. And I'll see you in the next video. Oh, if there is anything that you want me to talk about, just pop it in the comments and I'll do a video on it. See you again.